Hello everyone. So today we will solve lead code problem 287, that is find the duplicate number. We are given an array of integer nums containing n plus 1 integers where each integer is in the range 1 to n inclusive, and there is only one repeated number in nums and we have to return this repeated number. So let's head over to our drawing explanation and see how do we solve this problem. So an approach to do this would be a hash map. So what we will do is, when we will iterate through our array, we will check if this number is present in our hash map. If it is not present, then we will add it. Then we will move on to the next number. We will check if it is present in our hash map. If it is not present, we will add it. We will check the other number. If not present, we will add it. We check the other number. If not present, we would add it. And once we check this number, we can see this number is present in our hash map, so we would just return that number. So yeah, this would be one approach. So our time complexity in this will be big O of n, as we are traversing the array once, and our space complexity would be big O of n, because if the size of the array would increase, the number of integers increase, so our space complexity would also increase. So now we will look at a way where we could find a solution with the space complexity of big O of 1, that is a constant extra space. So to solve this problem with constant extra space, we can use Floyd cycle finding algorithm. And that is because we are given certain conditions. For example, we have a condition that our range would be 1 to n, while we are having n plus 1 integers. So if you would see in this array, we are having 5 integers. But at the same time, our range is from 1 to 4. So if you would look closely at this problem looks more or less like a linked list cycle problem. In lead code, if you go to linked list cycle 2, you might relate to this problem. So to understand this problem more, let's see how we can relate this. So if we consider our nodes, if we consider our indexes in this array to be nodes of a linked list, we can understand this better. For example, our 0th index, we start at our 0th index. So it's pointing to our first index. Now this is pointing, if you see, to our third index. So it will be our, now our 3 is pointing to our second index. So we are just keeping track of the indices and they are our nodes. So from here, if you see, our 2 is pointing to 4 and our 4 is pointing to 2. So we can see that there is a cycle. If we see this is like a linked list cycle problem. So what we can do is, we will take two pointers, that is slow and fast, and we will move our slow pointer by one step and we will move our fast pointer by two step. So at a point we will get our slow pointer, like we will get our slow and fast at a single point. So once we have got that, to find the duplicate number, what we will do is we will reset our first pointer to the initial position, that is here. We will reset our fast pointer to our initial position, and after that we will move slow by one step and fast by also one step. So we would come here again. So when they would meet again, we would be just returning that position, and that's how we would find the duplicate number. So let's see it with a dry run. So we have got our slow pointer and fast pointer here. Our slow will move one step, our fast will move two step. Our slow will move one step, our fast will move two step. Our slow will move one step, our fast will move 2 steps. So our fast will be here only. It will come back to here. Then our slow will move 1 step. So this is where they would meet. Slow and our slow and fast would meet. And that's when we will realize that our linked list has a cycle. That whatever array we have, it has got a cycle in it. So after that, we would reset our fast. We would just reset our fast. And once we have done this, let's see how that goes. So I would just remove all of this. So our slow was here. We have reset our fast to here. So in the next iteration, what will happen? They both will move 1 time. So our fast will come here, our slow will come here. Our fast will come here, our slow will come here. Our fast will come here, our slow will come here. So this is the position where they would meet, and this would be our duplicate number. So yeah, this would be the logic behind finding our duplicate number. So let's try and code this and put more sense into it. So the first way we discussed was a hash map. So we would do that. Then we will iterate to our array and we would add that in our set. If it is not present, if it is present, then we would just return that number. If n in hash set, then we would return n, and if not, we would just add that into our hash set. So we would add n. Now let's run this and see if we are getting any errors. So our test cases got passed. Let's submit it. Yeah, so this is one way of doing this problem. Let's head over to do another way. We will have 2 pointers. So one would be slow at the initial position and fast also. So this would be nums of 0. Then after that, we will check if our slow is not equals to fast. We will move our slow by 1 step and we will move our fast by 2 steps. Then we will reset our slow to the initial position and then we will check if while our slow will not be equals to fast, we would move our slow by 1 step. We will also move our fast by 1 step. Now we will just return our fast. So let's run this. Yeah, so this is how we would do it with our Floyd cycle detecting algorithm. So yeah, thanks for watching this video. I'll see you in the next one.